Hey, what's up guys? Welcome back to Eureka, and in this video we're going to be talking about the magnitude of a vector, and we're going to dive a little bit deeper into unit vectors. So from the last video we arrived at the formula vector v is equal to the magnitude of v cosine theta I plus magnitude of v sine theta j, which is equal to magnitude of v times the unit vector in the direction of v. So what does this equation actually mean? We see that we have two vectors being added together, right? And I is a vector and j is a vector, right? And then we have those quantities, magnitude of v cosine theta and magnitude of v sine theta. Those are the scalars that are being multiplied to I or j, meaning that vector v is equal to how much you want to go in the x direction, v sub x, times I. So you want to scale the unit vector I by v sub x, right? Same thing for v sub y, you scale j up, right? So let me actually draw a coordinate axis, x, y, and I'm going to draw my vector v. This is my vector v, right? And unit vectors, this will be I, that will be j. I, j. Remember from the first video, we said that the magnitude of a vector, the magnitude of the vector is equal to the length of the geometric vector. Now, I drew my vector starting from the origin, with its tail at the origin like this, until some point. For example, this vector, I don't know, is, this point is, looks like 3, 2. Meaning that instead of saying the length of the geometric vector, I will say the distance from the origin to the point, right? We're trying to find this length, right? Which is the distance from the origin to the point 3, 2. How do you find the distance? Look, this is a right triangle. Let me just draw a triangle. And this is 90 degrees, right? And vector v lies on the hypotenuse of the triangle. Now we know from Pythagorean theorem that, well, let me just write this again. This segment has a length of 3, and this is 2, right? So we want to find the length of the hypotenuse, which is the distance from the origin to the distance from the origin to the point, meaning that the magnitude of a vector is just the Pythagorean theorem applied to this right triangle here, which is x squared, which is 3 squared, plus y squared, which is 2 squared. Simplifying, this gives 9 plus 4 equals to radical 13. This is the magnitude of our vector v. In general, if you have any vector v, its magnitude is square root v sub x, which is in this case corresponding to 3, v sub x squared plus v sub y squared. Notice that I completely, I don't even care about I and j in this case, because I and j are vectors and the magnitude is a scalar. Okay, so that's equation number 1. Now let's move on to equation number 2, which is this quantity over here is equal to vector v, right? If we solve for the unit vector, meaning that the unit vector is equal to the vector itself divided by its magnitude, we can actually compute a unit vector. So, for example, given that, let's say v is equal to, let's see, 3i plus 4j, right? We want to find the unit vector in the direction of v. V looks something like this. Let me draw it here. 3i plus 4j, this is x, this is y. 3i means that you want to scale I 3 times. So, for example, this is 1, 2, 3, 1, 2, 3, 4. 0.34 is here, meaning that your vector, this is your vector. You want to scale, this is I unit vector, that's j unit vector. You multiply I 3 times and j 4 times, and then you add those vectors up, you get that the vector v, which is this one. Now, how do we actually compute the unit vector in this direction? Meaning that we want to compute a vector that looks something like this. It points in the direction of v but has a length of 1. How do we do it? Well, solving for unit vector, we get this formula over here. So we already have v. Let's find magnitude of v. Magnitude of v is Pythagoras theorem. 3 squared plus 4 squared equals to 9 plus 16 equals to radical 25 equal to 5. Right? You should always remember it's a 3, 4, 5 triangle. Okay, now that we have both the vector itself and its magnitude, we can find the unit vector, which is the unit vector is equal to the vector itself over magnitude, which is equal, write down the vector itself, which is 3i plus 4j all over 5, right? Now let's get 5 inside I and inside j, so it's 3 over 5i plus 4 over 5j. This is the unit vector in the direction of v. We can even check. Let's find the magnitude of this, right? So the magnitude of the unit vector, we know it's 1, but let's check. It's equal to square root of x squared, 3 over 5 squared, plus 4 over 5 squared equals to 9 over 25 plus 16 over 25 equals square root of 25 over 25 equals square root of 1 equals to 1. Magnitude of any unit vector is 1. That means our answer is correct. Okay guys, so I have an example here. I think this example will cover everything that we covered today. Hopefully, but let's just do it anyways. So, a ship traveled 25 kilometers along the direction u1 equals to negative 5i plus j, and then 10 kilometers along u2, which is 3i plus j. Find the ship's net displacement. Now, we're going to be talking about displacement more next chapter, but here's the idea. You're at point 1, you go to point 2. This is point 1, which is denoted by x1, y1, right? This first point, until the second point, which is x2, y2, right? Let's say the origin is here. This point can be described by a vector that's pointing towards that point, and another vector for the other point, right? So you're at point 1, you move to point 2, you displaced yourself, you moved. Your displacement is how much you moved. You move from this point to that point. This green vector is the displacement, right? All that this example is saying is you're following two paths. First is 25 kilometers, so how long is the first path? It's 25 kilometers. That means you have two paths, so let's name our vector as p, okay? So p1, the magnitude of p1, which is how long it is 25 kilometers, right? In the direction of this vector here, this vector. Now, directions we usually associated with unit vectors, right? Is that vector a unit? It's labeled as u, but there's no hat on it, so it's not a unit vector. So we need to find the unit vector in this direction, in the direction of u1. How do we do that? Let's see. U hat 1, the unit vector in the direction of u1, is equal to u1 over magnitude of u1, right? Which is equal to, what's the magnitude? Actually, let's just write this down. Negative 5i plus j over magnitude, right? What's magnitude? It's the square root of x squared, negative 5 squared, plus 1 squared, right? Equals to negative 5i plus j over, what's this? Negative 5 squared is 25, 1 squared is 1, 25 plus 1 is 26, radical 26. That's u hat 1. Let's do the same thing for u2. So now we have the second path. Magnitude of the second path is equal to, it's 10 kilometers. And let's find, sorry, didn't mean to do that. Let's find u hat 2. U hat 2. That's equal to u2 over magnitude of u2, which is 3I plus j over magnitude, which is radical 3 squared is 9 plus 1 squared is 1, which is equal to 3I plus j over radical 10. Right? Now, notice something. I wrote the units for distance, but no units for the unit vector. I'll show you why later. So, here's what the question is asking. You want to find the net displacement, meaning that you add those two displacements up, right? And those displacements are vector quantities. And vectors, a vector v is equal to the magnitude times its direction, right? We want to find the vector p1 and the vector p2. Vector p1 is, let me just write it down, vector p1 is equal to magnitude of p1, those should be vectors here, sorry, times the what's it called, the unit vector in the direction of p1, which is u hat 1. We calculated up there. Let's just substitute everything in. We get 25 25 over radical 26 into negative 5I plus j. Right? That's vector p1. Vector p2, same thing. Is the magnitude of vector p2 times u hat 2, which is equal to 10 over radical 10, 3I plus j. So this means we need to add those two vectors together to get a net displacement. Net means total, right? So our net displacement, which I'll denote by delta S, the notation that delta will be explained next chapter, so don't worry about it. This is equal to P1 plus P2, right? Which is equal to 25 over radical 26 into negative 5I plus j plus 10 over radical 10, 3I plus j. I think you can distribute and simplify, grouping the I terms and j terms. You will get delta S is approximately equal to, let's see, it's negative 15I plus 8j. The reason why unit vectors have no units is because, here, when I calculated the vector p1, I multiplied magnitude p1 times unit vector, right? I forgot to put kilometers here. So there should be kilometers, there should be kilometers. So as you can see, the vectors, they have units, right? But if, for example, the unit vectors, they have units as well, there'll be kilometer here. That means our answer will be kilometers squared, which we of course do not want. So we say that the unit vector is unitless. Alright guys, so I think this should cover everything for this video. It's a short one, I know, but the concepts are really important. First of all, this equation holds true nearly always. The unit vector is equal to the vector itself over magnitude. And the second equation, which is really important as well, is magnitude. The magnitude is computed by the Pythagoras theorem, meaning that you square root the sum of the squares of its components, basically. So vx squared plus vy squared, all square root. If you have any questions, please leave in the comment down below, and as always, easy.